Hey, here we go. So today it's talking about measuring in the coordinate plane. And in the coordinate plane, we are going to be using the distance formula and the midpoint formula. And you guys used those last year, so it's going to be a bit of a review. The distance formula isn't always the most appealing thing to use because it's a little longer. It looks a little weird. Okay, the midpoint formula is a little easier to use, but you've applied them last year, so hopefully we can tie into that learning to help you out a bit. Okay, so in your textbook, I need you to get the distance formula down, the midpoint formula down. If you know them by heart, then you can just write them down. But there you go. Ready? Distance formula. Distance formula is, well, what do we have? D equals what? Carson?
Square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared.
All right, so the quantities there squared. Okay, that is our distance formula. Logan?
Okay, I have a question. Wouldn't one, like, when you squared something, wouldn't it cancel out
The square root? That's a good question. We'll check that out here in a while. Everyone understand what he's asking? Like, will these two squares just cancel out that square root symbol? Okay, well, actually, let's talk about that right now. Let's say I square a number. Say, like, I square 4. What do I get? 16. So if I have 16, give me another square. Square like 5. What do I get? 25. Okay. And let's say I take the square root of them. To answer that question, will this cancel? Will the squares cancel that? So another way of thinking of 16 is 4 squared, and that is 5 squared. Everyone agree? Okay. So will this cancel that? Well, let's try it. If I cancel that and that, what's 4 plus 5? 9. That answer is 9. Okay. What's 16 plus 25? 41. And the square root of 41, is that 9? It's not. Square root of 41 is about 6.5-ish. 6.5 or so. Okay. So, no, you can't cancel out like this. This is bad. We frown on it. Okay? Can't do that. So, really, it's a good question because it happens a lot. Really what happens is when you have a radical symbol, it's like having automatic grouping symbols inside. You've got to do the math inside prior to doing the root. Okay? So, PEMDAS, right? Parentheses, then exponents. The radical is considered an exponent. So, great question. The distance formula, please note that that's x2, x1, y2, y1. Those are coordinates. So if we're talking about 2 points there. For instance, if I had the point 5, 2 and the coordinate 3, negative 4, when I'm saying x2 and x1, I'm talking about two different x values. And I can number them any way. I could call that my first and that my second, or vice versa. y2 and y1, the only rule is that if I call this x1, I've got to call this y1. The 1s have to go together and the 2s have to go together. Okay? So when I'm plugging that in, just recall that substitution, x2, I now have 3. And x1, I now have 5. And we square it. And then y2, I now have negative 4. And y1, I now have 2. And I'm squaring that. So when I do the math there, I end up with 3 minus 5, or negative 2, quantity squared. So negative 2 squared. And negative 4 minus 2, or negative 6 squared. And that ends up giving us, what's this?
4.
That's 4, right? It's not negative 4 because negative times negative is positive. What's this? 36. So the distance between these two coordinates, if I were to graph them, would give me root 40. Square root of 40. Now I expect that you guys can simplify radicals. What perfect square goes into 40? 4. So remember, this simplifies to root 4 by root Yeah, root 10. And the square root of 4 is 2. So this is 2 root 10. How many of you remember how to simplify radicals from algebra? Okay, we're going to be using that a lot this year. Okay, so I'd expect you can go to that route, unless it says round to the nearest tenth, or if I tell you otherwise. Okay, now depending on who you had as your algebra teacher, some algebra teachers really do quite a bit of work trying to go through the process of explaining why the distance formula is what it is. Really, how many of you know why the distance formula works? Okay, so if I have the xy axis here, and I plot 5, 2, all right, and I plot 3, negative 4, and I draw these lines, or draw that line connecting the 2 points. That's the distance I just found. Okay, using that information, I'm going to make a right triangle out of this. Tell your neighbor, talk about how you can find this length without using necessarily that formula and using right triangles. Go for it. All right, a volunteer to explain to me another way of finding the distance or that length. Madison?
A squared plus B squared equals C squared.
Okay, a squared plus b squared equals c squared. A squared is this length or that length. We'll say, right now I'm going to go with this length. So from here to there, how far is that? 2. Okay, and b squared would be from here to here. How far is that? Or that's b, excuse me. It's 6. Okay, so you're counting those points, right? Now note that when I square 2, what do I get? 4. And when I square 6, what do I get? 36. Now if you'll notice, that 2 and that 6, when I square them, that gives me that 4 and that 36. Okay? So really, when you're doing the Pythagorean theorem, which is what that is, the a squared plus b squared equals c squared, when you're doing the Pythagorean theorem, you're actually doing the distance formula, or more so, when you're doing the distance formula, you're actually doing the Pythagorean theorem. Okay? Any questions there? All right, so how many of you are familiar with the Pythagorean theorem? Something I think most of you had in 8th grade. We didn't do a lot of it in geometry or in algebra. Yeah, that's just your a squared plus b squared equals c squared. And thinking about it, c is the same thing as our distance here, our d. We can think of it that way. That's our d squared. So a squared plus b squared equals d squared. How do I get d by itself? How do I get rid of a square? Yeah, you root it. Okay, you make this a big square root symbol. And that's all you've done here. Okay? This thing represents your a squared. This thing represents your b squared. So you have a squared plus b squared, those distances, equals your equals your c, or your d in this case. Okay? If you don't like that, and you're like, that's tougher, then just use the distance formula. That's okay. All right. Questions? Midpoint. What's the midpoint formula? A lot easier than distance formula. You're finding the midpoint of a line. Go for it.
M equals, in parentheses, x1 plus x2 over 2.
Whoops, that's an x. All right. 2 over 2. All right.
Comma, y1 plus y2 over 2.
Okay. Good. Now, some of you may have y2 plus y1 and x2 plus x1. You can add in any order. It doesn't matter. Remember, this is supposed to be an x2 right here. I know it looks a little fuzzy. It's an x2. Okay. Remember, this is a coordinate. When you're finding the midpoint of something, you're finding the midpoint. You're finding the middle point. Okay. Halfway between. So, like, if I was to find the midpoint of this line, okay, I'm finding somewhere in the middle here. It's a coordinate. Okay, so using those same points we used earlier, which would give us the midpoint there, So if I add 5, 2, and 3, negative 4, I want everyone right now to use these coordinates to find the midpoint. Okay? Go for it. Neighbors. Same answers? All right. So when I put my values in, I've got our 5 for x1 or x2 is 3. That ends up giving me 5 plus 3, or 8 over 2, which is 4. All right. And then we have our 2 and negative 4, and 2 and negative 4 is negative 2 over 2, which is negative 1. How many got that? Okay, 4, negative 1. That is the midpoint. Now let's see if that matches up with our picture. Pretty close, right? 1, 2, 3, 4, and negative 1. I said about right there, but if I would have checked out my slope, over 1, down 3, over 1, down 3. That is the middle part right there, 4, negative 1. Okay, so the distance and midpoint formula help you so you don't have to go through the process of graphing every time. Saves you a lot of time. All right, any questions on it? Okay, so what I want you to do is I want you to take a look at this. This is the first problem off your assignment today, or off part of your assignment. It's number 1. I'm going to hand out your assignment while you're looking at it, but go ahead and talk to your neighbor about how you're going to solve that using that picture. I'm going to talk to you guys about that. You guys, your assignment generally depends upon how much we can talk about this in class and how much you convince me, how much practice you need. Okay, it's based upon your participation and how I feel you need to practice here. So let's participate, and that'll help out there. Number 1, the graph of Juan's newspaper route. Okay, so we've got our graph here. Find the distance between Parker and Commonwealth. So what was your plan of attack on that? Grace? Okay, so you were first going to start by finding the coordinates, okay, and plug it into your distance formula. How many planned on doing that? Okay, so that's one route. We can start by finding the coordinates. So this is 3, 2. And Parker is what? 1, negative 3. Did I have those right? Okay. And then using your distance formula, that's one route. What's another route you could go? Is it 2? For Parker? I think it's 1.
Yeah.
Yeah. Did anyone think about doing Pythagorean theorem? Is that what you're thinking? Okay, yeah. You also do the Pythagorean theorem. If you wanted to make a right triangle, you could go that route. Remember, distance formula and Pythagorean theorem kind of work the same. They're the same. The distance formula is taken from the Pythagorean theorem. Okay? So this length right here, that length is part of our distance formula. That length is part of our distance formula when we square them. Okay? But if you just want to use the distance formula and say, hey, that's x2 minus x1 squared plus y2 minus y1 squared, you can go that route as well. No matter what, I want you to find the distance right now between Parker and Commonwealth. Go for it. Okay, now you may have labeled your points differently than I did, but you should come up with the same answer. How many of you actually labeled your points like this? In that order, you called Parker your x1s and Commonwealth your x2s. How many switched them around? Called it the other way? Okay. How many you labeled your points? Okay. How many called Parker x2? How many called Commonwealth x2? Okay. All right. Just curious. So x2, if I do that, I get our 3, and I have minus 1 squared. 3 minus 1, that's 2 squared. And we have plus, what do we end up over here? y2 minus y1? Anyone? So 2, negative 3. Now notice I have a double negative here. That means plus, right? Which is what down here? Everyone? 5. That wasn't everyone. That was close to like 1/3 of us, maybe 1/4 of us. Okay? What's 2 squared? 5 squared. And we get root 29. Can that be simplified? No, it can't be. There isn't a perfect square that goes into it. So the answer is root 29. That's the distance. Now, if it says round to the nearest tenth, then you could do that, but it doesn't here. So we're going to leave it as root 29. Okay, now you could have done the Pythagorean theorem same way. That would have given you this length as 1, or excuse me. Is that right? Yeah, 2. Okay, so 2 squared is 4. It'd give you this length, which is 5. 5 squared is 25, which makes this 25 plus 4 is root 29. Same route, a squared plus b squared equals c squared. Okay. All right, I'm not sure that I'm totally convinced yet. Hopefully we do better on this one. Number 5. Let's try this. Find the coordinates of the midpoint of AB with those endpoints. Ready, go. Work together. Okay, remember your your midpoint formula. Now, notice I put the 2's first. That's just a habit I have when I'm dealing with points, but it doesn't matter what order you add them in. So I have 4 plus negative 3 over 2, and I have 6 plus 8 over 2. It doesn't matter the order there. Okay? So 4 plus negative 3 is 1 over 2, and this is 14 over 2, also known as 7. How many got 1/2 7? Yeah, mano. Which one's easier, distance or midpoint? Midpoint. Some of you find the distance pretty easy, but I think midpoint's a little easier. Okay, let's go ahead and take a look at the assignment. Let's cross out the example side. We'll just do mixed side today. First thing you need to do on assignments, just read through each set and make sure you understand what's being expected or asked of you to do. So right now, read through each set. Okay, some great questions came up here. What questions do we have? Grace. Yeah, where is a coordinate plane? What is a coordinate plane? A coordinate plane is just, Bethany knows. Go for it, Bethany. What's a coordinate plane?
A coordinate is where the point lies on the graph.
Yeah, it's like where it is in a graph. Coordinate plane is a graph. It's an XY axis. Okay? So graph each point in a coordinate plane. Graph it on an XY axis.
Do they have to be on their own plane, or can they be on the same one?
Do they have to be on their own plane, or can you just graph them all on the same graph? You can graph them all on the same graph. You just give them their names. Like number 1 is named A. Number 2 is named B. And so on. That little letter next to the point, that is the name of that point. So that's how you label it. Any other questions? Someone else up here had a question about graph paper. Do we have to use graph paper? Should this be on graph paper? Will we need graph paper? Yes to all of those. You need graph paper. Okay? Graph paper on the stool if you need some. Okay?
Wait, Rory, you need some?
Haley has a question. Go for it.
I don't really get what they're asking on 22.
Good. Well, I'm sure everyone's read 22. Who has not read 22 yet? You should read through it now because it's one that some students are like, huh? What's that mean? Number 22 starts talking about crows flying. A crow flies to a point that is 1 mile east and 20 miles south. How far does the crow fly? Well, one thing to think about when you're dealing with that, you're actually, the crow, anytime they talk about something flying or moving, we always start it at the origin, at 0, 0. So that is one coordinate. And then if you think of a compass, right here, even if you're not distracting like me or other people, or she wants to talk to you guys want to talk, you distract people around you. Okay? So we think of a compass, this is north, this is south, this is east, this is west. So if a crow starts at 0, 0, goes 1 mile east, and then 20 miles south, where are they at down here?
Oh, were we doing 120?
120. How far does the crow fly? Okay, I'm going to leave it at there for you. Okay? Oh, good thinking. Yeah, we're going downward. Negative 20. Good call. Okay. The other thing I haven't heard yet in terms of questions, it usually doesn't come up until you plot the points, but it says quadrilateral PQSR has coordinates this. Sketch quadrilateral PQSR. This is like dot to dot. You connect your points in that order. So when you're drawing your line, start at P, go to Q, then go to S, then go to R. Okay? That should draw your quadrilateral out. If not, then they gave you it in the wrong order. Okay? Other questions there? They're all great questions, man. I think we addressed everything that we need to. Bethany.
So on the first one, when we have to graph it, after you graph the points, do you want us to connect it?
No. Just graph the points.
Just, and then label them?
Yep.
Okay.
Yes, sir.
I'm gonna need to make like more than one graph, so like not just one big one, but we have more than one.
For this,
Not for that, but like all the other questions.
you may need more than one graph, yeah. Probably. It'd be helpful. Now, note that like on these down here, I would guess, I'm hoping that you don't have to graph them, right? You have formulas for them. Okay? But some of these you'd want to graph, like numbers 23 through 25. Here, if you want to label, you'd label them A, B, C, D, E. But for correcting purposes, it may even be easy to label, just as easy to label it number 1, number 2, number 3, number 4, number 5. Just because when you're grading tomorrow, you want to be able to find those points quickly. Okay, very good. Good questions. Work together. Ask for help. Woohoo!